Okay, so what we have here is a Python project where I have some code which is in this window over here. You don't really need to see all of it. We're going to change this one, number of samples as we go. Sample size, we might change that. Let's have a bit of a look, but that's really activity 2. So we're going to explore activity 1. Number of samples is 6. When I run this, it's going to produce for me a new sample, like the one that we did in the investigation. So let's do that, and it's going to produce for me a histogram, which I'll bring in here. And that one actually looks really good, except we know that it should be centered around 5.5. But look at it, it's very symmetric. It's got the beginnings of a normalish sort of look, but they're not all going to look like that. If we run it again, different sample, very much as sort of in this case, we've got a bit of a positive skew going on. And then we'll do a couple more and see the different things we can get. Here we go. Here's one with clusters and clusters and gaps. Let's do one more of those. And look, very different again. So we are definitely moving away from the 1s and the 10s, as we said, but we're not really getting a consistent view, and that's because we're taking a very small number of samples. So let's up the samples to, what did we do before, 25. And let's see what that looks like. Well, this one looks pretty good. The highest bar is on the 5 to 6. Let's do another couple of those. Not quite as good, I would say. But you can see the variability in them. And this one, we have a gap over here, and we've got maybe some more extreme values than we had in some of the earlier samples that we looked at. So that's all good, but if we actually whack this up to, let's say, 25,000 or something, it might take a little longer to run, probably not a lot. And there we go. That looks quite normalish. This bar's a bit higher than that one, but this is why you have to have a lot of samples before you get the picture of the actual distribution here. And let's leave that there at 25,000. Let's do one more of those, and you can see it looks a little bit different to the last one, but it's more consistent, isn't it? And you just expect that because you're taking more samples, so the variability smooths out a bit. Might be worth just changing the sample size. And it might not look that great with this particular program. If we do that, let's just whack it up to 16 or something. And can you see that that is just more centrally clustered? And once again, let's do that. You can see there's less bars out to the side. It's more around the middle and looks quite normal. So the reason this one actually flattens with n equals 4 into something that is normal is because the original distribution is symmetric, and we're going to see something different in the next activity.